Yeah, we're live in the morning, 8:17 this morning. Let's talk about getting your projects done. So I want you to come on as soon as you get here. Let me know what you worked on yesterday because it was Saturday, or today because it's Sunday. It's the weekend. It's the start of a new month. We talked about making a list and checking it twice, and you're going to find out which part is naughty and nice, which one cooperates and which one doesn't, because a lot of times they don't want to cooperate. How many times have you worked on a car and have bolts be stripped and broken and rusty and something? And that's especially the case back. And I was noticed that when I was back and went to visit the guys at the car farm, they were very excited about work. Well, maybe excited is the wrong word. Excited about working on a car from California because there wasn't any rust on it, and every bolt wasn't just like hadn't rust welded itself to the stud or the bolt into the block or the exhaust manifold and all that stuff, and you got to chip away like years and years of rust before you can get that stuff off. So they were excited about that, and it's much nicer to do that. But we run into that a lot when we're at the wrecking yard. We get stuff because things have been on there for 100, 200, 300,000 miles. It decides that it kind of wants to be permanent. So they always don't cooperate. This is a good example. If you take a look at the photo that I have up of the thumbnail, you'll see that this was a turbo kit that I made for the 292 inline 6-cylinder Chevy, given to me by David Freiberger. Thank you again for that. It's in the process of being rebuilt now. But the interesting thing is that if you take a look at the photo, you'll see the turbo kit that I made, and when I go back and look at some of these photos, I'm like, why would you do that? It's like so many different kinds of wrong. But also, while I'm doing it, there are things that you do that you get away with, and for some reason it still seems to work. So it doesn't always go bad. Sometimes things go right, and that's what we're going to talk about today. That there are lots of things that we can get away with. For instance, we'll cover some of the things that on this 292, they're maybe not blatantly obvious from the photo, but these are all things that people talk about when you do, if I do a video and I post the results of this and say, we did this and it did this, and they're like, oh, but this is wrong and this is wrong and this is wrong and this is wrong. And yet, as a turbo combination, it still works. So what the things that are wrong in this photo include the following. So if you take a look at it, the first thing you'll notice is that this turbo kit is just gigantic, primarily in length. And this was done not by original design, but by necessity. What I wanted to do was, I didn't have a dedicated turbo manifold for it at the time when I ran this test. Later on, I was loaned one, but this stuff took so long that I ended up giving it back. But what I wanted to do was make this work using a stock exhaust manifold, using a length of pipe off of the stock exhaust manifold. And then I had bends that were already done, basically elbows that already had, like I have the 90-degree elbows that already have the provision for the wastegate. They have the flange for the turbo. They have a V-band on the other side. So I can basically, what I normally use those for is I have the exhaust manifolds come out, the headers for LSs or for big blocks or whatever. Then they run into 90s that go straight up. The wastegate sticks straight out in the direction of the flow, which works really good. And then the turbos mount on these had T4 flanges on them. And that works really well, but those are fixed in their design, and I have those already. So rather than making brand new ones and welding up dedicated fittings or dedicated exhaust sections for a 292, which I'm not going to run a lot of turbo stuff on, I'm just going to run it and so that it gets boost, because everything deserves boost. We wanted to make that work. Well, the way that it's designed, if I mounted it just as an elbow coming off, then the turbo would be oriented improperly. And so I had to put another 90 section on there and then connect that 90 to another 90. And pretty soon this gets pretty long. And then also I have to mount the turbo. And then, as you see, the air to water intercooler, and then the piping going from the intercooler going back over. And so pretty soon I've got this gigantic lever arm going out away from the inline 6-cylinder. And this becomes even more problematic when you're trying to put lots of temperature, which you do when you're running a turbo, when you put lots of temperature in the exhaust, what happens is that you soften the exhaust up and everything just wants to bend down. So if you look closely at the photo, you'll see I have a ladder sitting there, and then I have the fittings coming out of the intercooler, and then I have them basically being supported by the ladder, and we have them attached there so that when this thing does get hot and all of this leverage is happening, that it doesn't want to just kind of sag over and touch the ground. Because we have had that stuff happen. I noticed when I ran the HP Performance twin turbo setup on the modular Ford, the way that they have it, there are exhaust manifolds, and then they run the tubes forward and put the turbos basically up in the bumper. So we ran the kit the way that it goes in the car rather than the way that I normally do it. And because we have, so much out there, when you're running the thing and you're getting them heated up, and you can see they're glowing, they're glowing orange hot or whatever, you can see the exhaust manifolds and the big tubes off them. You can see them all start to like bend down, and you can watch that happen. It's pretty interesting. Although, the cure for that is just like we did with the ladder, is you just got to put support there. And then that's why a lot of guys on the turbo stuff, they'll run supports off of the cylinder head over to the turbo just to help, stop it in the right plane, stop it from wanting to lever over and sag. It's important because even though the exhaust feels like, when you attach a turbo to the exhaust section, if the turbo is fairly close, it feels like all that's fairly sturdy, but it really does need extra support because, as I said, when you heat that up, especially thin wall header tubing or that kind of stuff, it definitely wants to move around, and so it's important to have that sort of support. So that's one of the things, is the length of the exhaust, and also the discharge tube is pretty lengthy. Although, as we saw in the video that I did, that didn't seem to have a big effect on either power or response rate, because I made a dramatic change in the discharge length and the diameter. We made it both really big, much bigger, and then made it really long in the front of the motor, because when I was doing the testing of the remote turbos, we made the exhaust section really long, which that did seem to have an effect, and then made the discharge side really long. That had less of an effect. So it was interesting, because that's always one of the concerns for people, is that, well, when I put a front mounted intercooler on it and I've got to run this pipe all the way over here, does it do a lot? It didn't seem to have a big effect, although we already had an intercooler and some length of pipe. So maybe there's a length where, hey, this is going to kind of be the same, but it didn't seem to have a big effect on changing the response rate. But again, on the engine dyno, not an ideal place to really test response rate stuff. The next thing is that's wrong on this turbo 292 inline six cylinder is the size of the turbo. This is a 76 millimeter turbo that I had from CX Racing. Again, this stuff was made with stuff that I had just laying around, so we use that, and that's not the right size turbo for what we're trying to get done. So it could have been better, but as it turned out, it worked out okay, because this 292 wants to make peak power below 5,000 RPM. So in fact, quite a bit below. And so that means that we're only in the area where it makes more torque than horsepower. So that we never even get to the crossover point where it starts making more horsepower than torque, as the torque curve is plummeting down. So we're making lots and lots of torque, basically. This thing is, you could consider to be more like a diesel application where it's really low RPM, but the turbo sizing was wrong for that, and we could have put a much smaller turbo on it. It had to be more responsive. The other thing that's going on with this is it has as you see, we're going from the air to water intercooler over to a blow through hat. This one was from CSU that we normally use on their 4-barrel, the blow through carburetor. But this, because it had a 1-barrel opening for the intake manifold, we used an adapter to go from the 1-barrel to a 2-barrel, and then we put this 4412 Holley, very common in various forms of like roundy round racing, circle track racing. We put that carburetor on there and ran it as a blow through. Two things are wrong with that. One, that's not a blow through carburetor. We just did it anyway. And also we ran E85. And so not only is it not a blow through carburetor, it's also not a blow through E85 carburetor. but all we did was just jet the thing way up. I think we put 100 jets in it or something, and just to get the air fuel where we wanted it to be, a wide open throttle. And that works okay for wide open throttle, but it does not work for transition or driving. So it's not something you could actually do out on the street, at least not very well. You would have to do more than that. The metering block would need to be an E85, and it would have to be sized for that. But yet again, on the dyno, not a big deal, because we're just we get it to the point where it's at wide open throttle, and then once it's there with the jetting, the air fuel is pretty good in the 11s, let's say, and it could be from mid to high 10s up to 12, 1 or 2 or something like that, and still be safe for what we're doing. It's not going to hurt itself doing that. So we could adjust the jetting to the big size with the 85 because we needed more fuel flow, and then get the air fuel right. And yet that our non-blow through non-E85 carburetor, because we just threw a bunch of jet at it, blowing through that 4412, worked okay for the dyno. The other thing that's wrong with this, and it would be impossible to see from the photo, but this engine configuration, the 292, originally came with a points distributor, and this was not ideal for what we were trying to do, and certainly not with the worn out points that were in it. Those definitely needed to be changed, and we didn't do that. So we were fighting a misfire issue while we were doing this, and we had to bring the plug gap way down, and I should have just put points in it or tried. I think we may have even tried adjusting it, but I think the points were kind of worn out. We should have. Somebody sent me an HEI distributor for this, and that would have been the cure to put it in. And when we go and run this test again, we'll definitely do that. We can try it with points, with new points, and that will work, because it's really just kind of a triggering mechanism, although the dwell time is going to change the spark energy. But it will work for this kind of power level. We were only running 6 or 7 pounds or something on this combination, so it would definitely work there. But a modern electronic distributor is just it's just a way better choice, especially because if we run that, then we have more spark energy, and we have ignition amplifiers that we can run on the dyno, and it's plumbed that way, it's hooked up that way, and it's just much easier just to plug everything in and work at the way that we do all the other V8s and stuff. So those are all the things that we did wrong. And even though all of these things are obviously not ideal, it still worked. It still ran, and it still made boost because they want to run, they want to work. And so if you're adding boost to some kind of combination that you have, if you can get the timing within the safe range and get the air fuel within the safe range, it will actually work, even though you have the wrong size turbo and your exhaust is too long, and you have the wrong carburetor, and you have the wrong distributor and stuff. With a distributor, you may have to cure some issues with misfire, but once you do that, it will all work. And so when people are struggling with stuff, they need to realize that the turbo itself is not really the problem, because it's going to do what it's supposed to do, as long as you can get the exhaust flow to it. If you can get the naturally aspirated motor running correctly, and then you put the turbo on, and then you can add the necessary fuel and take away the timing, that's it. It's not, there's no magic stuff after that. It's just that. And so even though we did a lot of those things part way or incorrectly, it still did fairly well. And so now that after discussing this about the 292, I want to put that back together. And I think that it's ready to go back together. I think that all we have to do is put the head back on there, if I remember right. So it should be ready to go back together. And then I could redo the intake test that we ran on there and see what kind of, there are Clifford intake manifolds and PES ones and all kinds of stuff that can help. And, you do the same things. You port the head. Although the thing that I don't like about the 292 is I don't like the Siamese port head. I know that there are ways to get around that, and there were ways to port it, and you could put the lump port and all that stuff. And I've been through all of that, but I still don't like the Siamese port. I would rather have them have individual ports. I like that much better. That's just me. Are you guys, let's see what you guys got going on today. What kind of projects you got going? I'm getting ready to take a trip down to West Tech so that I can get I'm excited about doing the 2.2 about getting that together. I'll probably do a build video on that, on how to put that thing together, get everything lined up, get the sprockets lined up, get the distributor lined up. And we'll do the same thing that we did on the one that I put together for the Omni. So we'll pre-oil it. That worked out really well. I like that. I always like when we run stuff on the dyno before we run it, especially if it's a brand new motor, we will go and if it's a small block Chevy or big block Chevy, small block Ford kind of thing, where we can spin the oil pump, we spin that up, make sure it has oil pressure. That's always a good start for it. That's also one of the first things that we do is pre-oil these motors, even from the wrecking yard, just to make sure that they have oil pressure, because that's always a good first start. And then the stuff from the wrecking yard, also, if it's sitting on the dyno, we can also do a cranking compression test. We can do a leak down test while the thing is sitting on an engine stand, even before that. But those are all good, like, pre-game checks, just to give you an idea whether the thing is going to work. You can even take the plugs out and kind of rotate it by hand and use your finger. That's just a go, no-go thing. It's not really telling you whether one is low or not, but you can tell by putting your finger over that if you crank at it and then it has resistance and air wants to blow out of it, well, there's some kind of sealing going on. It doesn't have a big open hole in that piston, or one of the valves isn't hung open or broke or bent. So that's a good no-go, no-go kind of indicator. And then when we put it on the dyno, before we hook up all of this stuff up, we make sure that it has oil pressure. And then we also make sure that we can do especially after we put oil in it, it has oil pressure, we can spin the thing over and make sure that it has cranking compression, because you'll want to make sure that it has cranking compression, and you want to do that while the lifters are working, because that's important. So you want to get oil pressure to the lifters on a hydraulic or hydraulic roller application. So I like to do that and make sure that that stuff is working. And then if that stuff is working, usually we have pretty good luck with the rest of the stuff going well. We know that, okay, mechanically the big things are okay. Now we can go take a look at individual things and make sure that, even on a cranking compression test, it'll tell you if a cam is going flat, if a rocker's not there, which we saw like on the 4.8 liter. All of that stuff is a possibility. All that stuff happens. So let's see what you guys got going on. We've got to get a poll going this morning. Okay, so the poll for today is, should that 292 in the photo, should it get put back together and get boost properly this time? Should it get boost again? Let's see. Let's see, and we'll see what you guys got going on. Rebuilding the driver's side brakes, cleaning up a hurricane mess. Yeah, the stuff in Florida, that's tough, and then other states are now getting it too. How often does he stream on Sundays? I usually do the nighttime stream. The 7 p.m. stream is usually every Sunday and usually every day. Dan, you're at IHOP. I'm reading your book on building Honda K-Series engines, performance suggestions for a good foundation. The Honda K-Series by itself is already a good start for everything. If you're running boost, I would put ring gap in it. The nice thing about a K20 or a K24 A2 is if you're starting with that, put ring gap in it and put head studs on it and start putting boost to it. And then if you can run the 85, it's much better. 1996 F-150 will never see over 5,500 RPM. Would prefer torque. Was a recommendation. A 96 F-150, is it what motor is in it right now? If you want lots of torque, a 351 base stroker like a 393 or a 408 will give you lots and lots of torque. Peeled the 823s off of the LY last night after a chat because I couldn't sleep. Of course, my wife knows I smell like oil. Got to be more careful. I haven't graduated yet, so toys are a no-no. Greetings from the city. City's in the house, Mexico City. If it's the only 292 tested so far, it's the only one I've ever run. Finish up the lathe work with my trans spray bar. Cool. You have to make an oil pump pickup for the internal pump. Where are you getting oil for that? (1996) F-150 5-liter with OBD2. Okay, so you have a 302 in it. A 351 would definitely make more torque, and then a stroker 351 would be even better. NorCal, I have a fresh one on the stand with a comp cam in it. You're welcome to use it. You're only a few miles away. Is it a 292? Is that what you're talking about? What RPM can I spin the Gen 3 5.3 liter E85 14 with ring gap? You can spin it to whatever RPM you want, but depending on the combination that you put together, it's going to make power in that RPM range. There are guys spinning the short blocks to 8,000 RPM if you wanted to do that, but you don't need to do that on a turbo application. That's one of the good things about it. So the sump that you're using is in the transaxle, right, Dan? Is that what you're talking about? Richard, I'm going to email you about testing my home port heads. I think I did. I got an email from somebody already, or a message or something asking about that. I don't want to test somebody else's heads. If I'm going to do home porting on LS heads or something, I'll just do a set that I have. That way, we don't have to ship heads back and forth. But when you put them on, you can let me know how they do. Those are porting. Should I get the 292 back in and run boost on? 84% are saying yes. Toyota A131 3-speed auto has a separate fluid supply for the diff, which nobody knows and remembers to check. Well, if you don't check it, then it must be good, right? It's like cam bearings. When you look, that's when you know that it's bad or that it's empty. It's like Schrodinger's cat. So 85% saying yes, 15%. I'm surprised it's not a little higher than that. It's got some 292 haters going on. Hypothetically, early 70s Bronco, 302, 351 are finding something more stock. Well, a 351 is always a better choice than a 302. As long as it will fit. I don't know how early 70s you're talking about. As long as it should fit in that engine bay. The 351 has a much stronger block than a 302 because, as we all know, that the 302 is right at 400 horsepower. After that, if you make 401, then the block splits immediately. But a 351 won't do that, and you could make. It's a bigger motor. It'll be torqueier. A Bronco is going to be not light anyway, so the vehicle weight will definitely like having a lot more displacement and more torque, and then you can make always more power out of the bigger motor. Blue collar, are yours home ported stock heads like an E7TE head? GT40P Explorer 5 liter with some good valve springs and a proper cam would be decent. Schrodinger's cat's got a new meaning today, Dan. You look under there and you don't know whether your cat's there or not. I think if I do the 292, I think I'm going to try a little different turbo setup on it. One of the turbos at least in the same zip code as the engine is. An LS would make a good 351 Windsor. Yeah, that's true. And a 6 liter would be even better. Although both of those you can make 408s out of. Small block Chevy, 383, TFS 175 heads, Performer RPM 10 to 1, 213, 221, intended for a Blazer. Yeah, that'll be good. I'm assuming that that's like a 750 carburetor on that. Can you fit a Boss 429 in a 70s Bronco? Can you afford a Boss 429 and a 70s Bronco? Neither one of those are cheap these days. Although what year are the early smaller Broncos? Are those from the 60s? '66. That's what I thought. I thought that they were in the 60s. I like those little ones. We have a couple driving around our town that are really nicely done. '66 to '70. So they went all the way into the. They went all the way into the mid to late '70s. I didn't realize they went that far. I would have to go do some research on this. More information is always better. Broncos. It's on the list. One of the things that I went overboard on I was looking at the photo of the 292, one of the other 6 cylinders that I went a little overboard on is the turbo header for the Atlas. Jason from JT Fab, shout out to Jason, did a really good job on the headers. It's just that my design that I wanted him to make was probably way more elaborate. And quite possibly my design is not as effective as it would have been had it been shorter. I sat in new ones in the showroom when my folks were car shopping back in the day, or like a new Bronco now. Either a 750 or an MSD Atomic EFI. I would still go with a carburetor. A carburetor and a simple MSD distributor, or even a HEI distributor works really well for those too. The only thing on the HEI, you'll have plenty of spark energy. Another distributor is not going to get you any more power. One of the things you normally have to do on the HEIs, though, is limit the total advance. They've got a lot of centrifugal swing, so we have to limit those. I'm surprised we don't have a lot of people here today, but the ones that are here are the good ones. Dan Wagner Ford, where they campaigned a Torino stock car, sometimes driven by AJ Foyt. Nice. Now Bo Townsend Ford. Yeah, it's kind of cool that back in the day that the dealerships had their own race teams. That was kind of cool. I like the Torinos, especially the Torino Talladegas. Talladega Nights. Man, I hope everything goes together and goes well with the 2.2. I'm excited about that. The one thing I'm worried about on the 2.2 is the one that we took apart. You guys saw the video on it. The cylinder head was damaged. It just had eroded from the water passage over into the combustion chamber. So they had to weld that up and resurface it and stuff. And so I'm hoping that that holds together, at least for this testing. We're not going to try to make 1,000,000 horsepower with this early version, but I just want it to, and if it doesn't, I have another head in the garage, one that we're going to flow test, which I think would be quite an easy replacement. But what I want to do is go through the series of tests so that we can run the intake manifolds and different things on this early motor, and hopefully that will all work out as long as that thing cooperates. I don't think we're going to have to run. I need to look and see if need to check and see that we did the deck surface of the head and block for MLS gasket use. I don't know if we did that. I don't know if we did the drill and tap for larger head studs. Write myself notes, otherwise I'll forget. That's how you got started in the race game, Dan? Sunday morning, cold trickle. That's right. I want you to go out and hit the pace car. I was up late last night watching pro stock sled pulls at my local fair. So you were there in person? That's even better than watching it on TV. That's kind of cool. Plus, you get to have like fair food, corn dogs and stuff. Talk about one of the supercharger manifolds for a 292. Yeah, I think about that all the time. And I even thought about just making one for the. I just wanted to put one of the blowers from the M90s from the 3800s on it. Yeah, but now we're eating ice cream. That's right. Fair food and the smell of racing gas. That's a good combination because then you have corn dogs and cotton candy and stuff. Yeah, I can't imagine those manifolds are cheap, but it'd be easy to make something or just adapt something to something that's already there. Like it'd be really easy to adapt the supercharger to a plate and then just mount the plate to one of the 4-barrel manifolds that are already there. Because I do have a 4-barrel manifold for it. I have one of the Australian ones. Happy Sunday. The 292s have Siamese intake ports. So that's how the manifolds are too. And like with most motors, the intake manifold has wildly, they have longs and shorts on their intake design. So they're definitely going to be making power different engine speeds. Ford did integral manifolds on the 200s. Does that mean the head and the intake are all like one piece? Or did they do it on the exhaust? The head and the intake, okay. Yeah, I don't like that idea. I also don't like when I don't like the way that the new exhaust ports are done on some of the Hondas do it, and there are others too. Volkswagen did it, where they basically make the head into kind of an exhaust manifold with a single opening. Although maybe for a turbo application, it's really good. This doesn't have a, this 292 isn't like that. This 292 has a separate exhaust manifold because we ran a header on this 292, although it didn't fit very well. Two 292 has head bolts going through the ports. The lump port is a very good mod. Proper head on a bow tie inline 6-cylinder is the overhead cam. Do they share the same bore spacing and stuff? But I'm gonna put together the overhead cam Pontiac motor anyway. What's the name of the factory CTSV blower? Isn't that an LSA? My buddy fabbed up an M90 to a built 4.3 liter, made 500 horsepower. That's a lot of power for that M90. They do the exhaust port thing to reduce emissions. Yeah, mostly the emissions now happen at early startup. They're really concerned with that thing. That's why we want the cat so close to that. They're concerned with initial startup stuff because that's part of the testing cycle. When they cast the turbine housing into the exhaust, yeah, they do that. And you on the I see that on the blowers too. The cast intake manifold receives like the rotor pack. The Ford 200s, I have a video of a guy brought a really nice one in that was turbocharged. They weren't able to get it running right just yet because he was had to make some changes to it, but it was really cool. Having major trouble with belt slip and roll off of the BMW or the B&M 174 on a small block Ford. Have you ever had that? You got to have a misalignment problem. You need to take a look and see what is misaligned. Do you have the wrong? You need to look and see what's going on with the damper. Does the blower have angle to it? Is the snout like, instead of being perpendicular to the ground, does it have angle to it that wants to shoot the belt off? Is your tensioner, is it a guided tensioner? Are the guides pushing the belt one way or the other? Is that spacing not right? You just need to check it. I've run that 174 on small block Fords, on small block Chevys, on big blocks, and it's worked fine. I have videos up of running that blower on the small block Ford, and it worked good. It doesn't make the power, obviously, that turbos or centrifugal blowers do, but it's really, torquey and it's fun to drive around on. Why don't they use chains? They don't they don't want chains coming off and hurting people. Yeah, the chains almost have to be kind of contained for having the oil sling everywhere and for them not to break. Besides, the belts work good. I mean, and a cog belt will have no slip, but you don't really need that for that kind of blower. Richard, did you decide on a double roller for the LS? For which LS are you talking about? And I've that I can remember, I've never put a double roller chain on any LS, if that's what your question is. I don't think I ever have. The original GMC, they had a bunch of V-belts on it. If you've ever seen a high-speed chainsaw chain come off and wrap around, you'll not want to change it. That would be bad. I have had the chain come off of my chainsaw, but it's an electric Harbor Freight one. So it's just, it's not a good design. But I can't believe how many things I've cut down with it and how many fairly good size trees that I've cut down with it. And it works. I just did some lumberjacking the other day so that we could climb up to this top of this tree that's in the backyard and kind of sit up at the top. Yeah, Dan, that's the other option, is they can be mechanically coupled to the front of the crank and not be offset, basically, so that they have to be driven by a belt or a chain. My dad had a chain come off a chainsaw wrap around his hand. That's. I'm glad they didn't take his hand off. Can you do another truck cam test? I want to see the difference between a comp cam extreme truck cams and a truck Norris cam. You had a video talking about using it, Jaybird. I have to go scroll back and now see what you were talking about. Using it always on. Yeah, we normally put double roller chains on small block Chevys, but I don't ever do that on the LS. The chains that we use on the LS, especially when you use the upgraded chain from, I think it comes from Germany, guys are running those to like 8,500 or whatever. So that's good enough for me. And the double roller chain causes other problems with the LS for spacing. And so I don't want to go through that. If the thing already works, I don't try to make it work better. Was the saw ported too? No, it was electric. What it needed was a Kenny Bell boosted pump. I don't remember. I've never directly tested the truck Norris cam versus. I'd have to go back and look and see exactly what cams you're talking about. If you have part numbers on the comp stuff, I have a comp catalog. I don't know what year this is. This might be an old one. And see what cams you're talking about. I shipped my 5.7 at 7,400 and just use a C5R timing chain. Yeah, that works good. The K-Tech guys have a lot of racing experience, so they probably have a fairly good idea on what works and what doesn't work. But the chain thing is a fairly known commodity now for the LSs. And quite honestly, we've run lots of junkyard stuff to 7,000 and 7,500 with the old 200,000 or 300,000 mile chain that came from the factory, and I've never had one break. We need some LC9 VVT cam tests. I can't run VVT stuff because I don't have a way to control the variable cam timing. Thanks for the information. It has a spring-loaded tensioner pushing outward. I think it needs more belt wrap around the pulley. It's in a Fox body with a Tremec, so when you stomp on it, the belt slings off. Yeah, I'm not a big fan of the way that they tension those. Because I remember it has a mount coming off the snout and then pushes the belt outward, if I remember right. It's rolling. But you can certainly run a double roller if you want to space the cover or machine it, or then I think you have to space the oil pump out and stuff. LS cams don't drive the oil pump or a fuel pump. Nope, they don't do that unless spring pressure. That's right. All of those things are why that you don't need super double throwdown wazoo double roller timing chain. The oil pump's driven off of the crank because it's a gyro pump. We run most of those ones, or a lot of the LS stuff will run beehive springs, which are much less spring pressure. Although we run dual springs on a lot of stuff, but even those are not, they're not like they're like big black Chevy springs. I haven't heard a compelling reason why the knock control works in a moving vehicle and not on the engine dyno. The moving vehicle and the stationary dyno have nothing to do with why the knock sensor doesn't work. The knock sensor is tuned to a specific frequency and it wants to listen for certain things. When we run things on the dyno makes noises and modified engines now make noises that the factory motor does not make. And so it hears that stuff. And more often than not, what we get is false knock on there. And we don't need knock sensors anyway, because we know how to tune it so that it doesn't detonate. You'll never go wrong with a Cloy's true roller with a cast iron gear. A steel gear is not a good choice. It will wear out before a cast gear. Have you ever made a video on 5.3 versus 6.2? I don't know what the difference between those is that a bigger motor was going to make a lot more power. That's the benefit. A 6.2 is going to be an aluminum motor for one. It's going to be lighter. You could have a 5.3 that's aluminum, but there's also lots of 5.3s that are iron. But the benefit to that is it has a bigger bore. You have more cylinder head choices than a 5.3 because you can't run a rec port head on a 5.3 because the bore is too small. So the 6.2 is just going to be bigger and it has the potential to make a lot more power. There's not a reliability issue because both of those basically are the same engine family. Are beehives better on a small block Chevy than a dual spring with a dampener on a very mild roller cam? I would tend, on a mild application, I would tend toward a beehive or a single spring with a damper, but I would tend toward using a beehive. You'd have to go onto a Spintron to see what the frequency match is for what you're doing, but a beehive spring will work really well on that. Crowd cam, I picked 213 duration with 505 lift. That's not excessive. If it was 605 lift and a 213, then I would be concerned. So Motec says you have to knock the motor to actually have working knock control, and it's required with their system. Yeah, you have to tell it what frequency it needs to listen to. There's an awful lot of testing that goes into making the knock sensors work on factory systems. It's so hard, even at the OEM level, that some motors, some supercharged motors from the factory didn't come with knock sensors because it was too problematic for them. If you have no knock control, how do you know where the tune limit is? We know where the tune limit is because we can keep adding timing until it stops making power. When it stops making power, you're at the top of the power curve. And the only thing that will happen now is if you keep adding timing, you'll start losing power and then you'll start losing parts. That's how we know. Because we're running the motor so cold, and it has a good air source and it's basically a much friendlier environment for the motor, that we can put it into that situation before we get detonation. That's one of the benefits, because you usually can't do that in the street. But that's not the limit of the turbo or the engine. I can't remember running combinations where we maxed the turbo out. We may have, probably on the GT45 we have maxed it out. Do you do the initial tune with higher octane, then back it off? Yes, we do. Even on especially supercharged stuff or turbocharged stuff, we will run, and even nitrous stuff. Brule likes to run stuff and be safe first, and then you get everything right, and then you can start changing from, if you're running 85 or you're running 100, then you'd go to a 91 tune where you start taking timing off. Part number comp counts 54451, XFI Extreme Truck Cam 554, 558. Okay. What changes the knock sensor frequency? The knock sensor frequency is what it's listening to is fixed, but the or it probably has a range that it would think the detonation is. But other things like in the engine compartment, it's not going to have solid motor mounts. We have solid motor mounts. We have a drive coupling that makes noise. If you change to roller rockers, that induces another noise that it would then listen to. There are lots of things that rattle around basically on the dyno that you don't ever have that in the car. It looks like, being that your numbers are gross power compared to wheel, it always looks to me like there's a ton of power left on the table. There's not. If we run a naturally aspirated LS, you won't get any more power out of it. There isn't any more power to be had. There's nothing that you could do that's going to give it more power. Oh, but what about injector timing? Tuners. Mostly set on E85. That's really good. There's a good safety margin there, and it will definitely make more power. Dyno tuning is a balancing act between air, fuel, and timing. Once you get the best air fuel for your engine, then you can do timing sweeps. That's what we do, Racer. We get the thing. So like if it's on a boosted application, we run, let's say we pick 11.7 as the air fuel. In reality, you can run 11.5, you can run 12.0. You can do all those things and try to get more power. But as you add more timing, as you take away fuel, you get closer and closer to the problem areas. See how our poll is doing. 85% saying yes and 15% saying no. Oh, I love people that are not there. Super awesome. It's a much better route going from more timing and more safety to less than going the other way, throwing it all in on 91. Although now, because we've been doing this for 30 years, that you find out what works and what doesn't work. You could do it the other way. You could start on 91 and just have not very much timing in it, and then get the air fuel. But while you're doing a brand new combination and you're doing like on a carbureted small block, it's just going to work. I mean, we just start out with, if we know that the engine combination is going to want 35 degrees of timing, and we start off at 25, obviously it's not going to hurt itself, even if we're way off in the jet. And the nice thing about a carburetor is we're not going to be way off on the jet. If we take a carburetor out of the box, just sitting there, that ran on something else that we don't even remember what the jetting is, and we put it on there, it's actually going to be fairly close. If we roll into it, it's 14-1, we go, okay, well, let's throw jet at it. Let's throw 4 or 5 jets at it. And then if it's an NA one, we get it down into the 13s, or even better yet, the 12s. And we run it at 12-1 at 25 degrees. Okay, it likes that, it wants that, Okay, then we start going up in timing. And then if it changes the air fuel, which it doesn't seem to change it very much, we keep going up in timing, and we keep going up until it doesn't make any more power. And that's it. That's all the power that it makes. And then we can after that, if we really want to delve into it, we can try more jetting or less jetting. We can try staggered jetting. See, the what people don't realize is that when we're doing this, we're not looking to get the last 2 horsepower out of every combination. That's not normally what the dyno is. When I was doing engine masters, we're looking to do that. But on most of these things, we're not looking for that. It's not the last 1 horsepower or 2 horsepower out of every combination. That there isn't time or even the need to do that. If I'm doing 2 intake manifold tests and we see a 30 horsepower difference between those two, it doesn't matter if we see a 31 horsepower difference between those two or 32. That doesn't tell us any more than, hey, look, there's the single plane makes more power on top and the dual plane makes more power down below. And now you need to choose the thing that you want. Having 1 more horsepower doesn't do any of that. The money pool. Yeah, you heat that oil up a lot. You let the water cool off, run the fan, do whatever you're going to do, and you can get, the good power one. But my first timing change is always to reduce timing. That's a good way to go, but it depends on where you start. If we have a small block Ford and we start off at 25 degrees, running less timing, we can try that. But if your first jump in timing is to go from 25 to 27 degrees and it makes more power everywhere, you're going in the right direction. When people rent the dyno, they want every last horsepower there is to be found. You have a different mindset, and obviously nothing anybody says is going to be able to educate you, but that's not anywhere near accurate. That's not what testing is. That's a different thing. Building a motor and wanting to go race it and wanting every bit of horsepower out of it, every last 1 horsepower out of it, that's a different thing. That's a very, very tiny portion of what happens on the dyno. The testing part of it is a completely different thing that I do. And so you have your thing, obviously, and you're stuck in your mindset. That's fine. I was thinking of pulling a 5.3 out of junkyard for Silverado. This will be a farm truck, so no or limited highway use. Would a 25, 30 millimeter turbo for each bank or larger? You're going to need something bigger than that. I remember finishing a top 5 with 1 plug wire hanging off. It's not always about making horsepower. I remember when I was running World Challenge, we had a small block Ford, and we had equal length shorty headers on it, and they should just call those plug wire burners. And we ended up, because we didn't have another set, I just ended up putting layers of, we had a tube of silicone. And so we put layers of silicone and let it dry, put layers of silicone and layers of silicone so that the thing would just last for the race. Let's see. Yeah, 99 is when I think that's when the 99 and 2000, I think, is when they first introduced the LS, right? So it's been around what's that, a quarter of a century? Have you ever had a turbo surge when making a dyno pull? Yes, we've run the wrong size turbo on on an application and had it go into surge. It's not a good sound. And you can do that. You can hear that it makes a similar noise when you have no bypass valve and you do a hard decel. It's not good. Is it like a compressor stall on a jet engine? I don't think I've ever compressor stalled a jet engine that I can remember. Richard, is it necessary to run a reduced base circle cam in order to run a hydraulic roller and a non-hydraulic? Yeah, I think you do. I think you have to do that to put the, maybe they have a lifter that will be done properly. I think that the concern is putting the lifter oiling in the oiling groove on a block wasn't designed for hydraulic rollers. So I think that that's the critical thing, is having the oiling in the right spot. And I think that they do that either with a reduced base circle cam, or maybe their retrofit kits have a different lifter. I've had compressor surge on a streetcar. Oh, probably in a turbo Porsche too. The particular one sounded like an alley cat screeching under the hood. Kind of backfire, I think, jets when they compressor stall. I was doing dyno testing in '78. We were testing $400,000 wobble. What's a wobble pump, Dave? They would make 10 horsepower and 10,000 psi hydraulic pressure. That's a lot of pressure. You don't want to get your hand in front of that. So we're going to go ahead and close out our, should the 292 get put back together and get boost? 86% are saying yes and 14% are saying no. So we'll go ahead and close out our poll there. And we have 2 minutes. Ken's Exotic, you want to see the 292? I like it so much better when the motors are put back together and they're actually working. I hate having all these things apart. Good morning. Do you remember your source for the Nissan RB? It was some local place up by West Tech that we went to. Or can you just tell me yours? You can't find, there's got to be RB25s out there for sale. I'm sure that if I went online and did a search for them, you could find them. I'm definitely going to do testing with it before I would sell it. Fit the Ford E4 from a 4.9 to the Chevy 292, but then we have to make an injected intake manifold. We don't need fuel injection on it. Yeah, Dan, we get there are people that come in and would want to take the chance of adding another half degree of timing to get the number that they want at the expense of destroying the motor. And it's just silly. It's much better to leave 5 horsepower on the table and not run against the edge of detonation. And then when things change when it's in the car, then it's definitely going to hurt itself. It'd be much better to have a little bit less power and have it go out and make lap after lap after lap than it would be to find that detonation threshold. I think a lot will be surprised at the 292. I think it's going to do what every motor does. It will make this amount NA, and then we add boost, and it's just a multiplier of that. But I like the 292s. I like the inline 6-cylinders. I like the way that they sound on the dyno. It's definitely different than when we run the V8 stuff. I prioritize what the engine wants. The dyno tells me what works and what doesn't work. It doesn't work nearly as well if I try to make that go the other direction. So Dave, it went into stall and to damage the engine, so they had to land and do an engine swap. Did you do was it like a whole NASCAR pit crew going in and taking the engine off? Yeah, Ken, we'll definitely run a turbo on it again with hopefully a better looking turbo setup and probably a real blow through carburetor. Because if I run one of the intake manifolds that facilitates a 4-barrel carburetor, we can run the CSU blow through deal, and it will be. I mean, the 500 is a good size carburetor for that. It worked well, but we would like to run. Now that has me thinking we have to run E85. So, but I think we now have an E85 4-barrel blow through carburetor. Are you going to run one of the 1-inch lift cams on the 292? Yeah, it's just that you have to add all of the lifts up of all the cylinders, and then we'll get to 1 inch. Not only are they going to be 1 inch, but the lobes are going to be rectangular, because that's how all the cool guys do it. You're the only jet engine mechanic. See, look at that. That'd be a good shirt to have. You will make power. Cranks boost controller to the moon. The moon setting, offset 10 on the ignition. And then run it under closed loop and only allow it to take fuel away, not to ever add any, and only allow it to add timing. Baggage handlers. Okay, guys, time to get going. You guys go get all of your stuff done on a good Sunday, and I'm going to work on another video, and then I will see you guys all tonight. I got little red buttons. I get to push.